Hi ladies, it's Mr. O'Sullivan. Today is an ed puzzle lesson. There is no delta math. Please make sure that you answer the questions as you progress through the video. So today's learning target is I can apply my knowledge of geometric terms by marking an image and forming a conclusion. Your do now for this activity is to find the midpoint of this segment. So for question number 1, I want to find the midpoint of segment AB if A is 5, -2, and B is 7, 5. Well, if I wanted to, I could draw a line segment. And I know that A is 5, -2, and B is 7, 5. And I want to find that my midpoint, so right here, the halfway point, all I have to do is just add my x's, divide by 2, add my y's, divide by 2. So I'm going to do, my midpoint is equal to x1 plus x2 over 2, y1 plus y2 over 2. So if you look, my x values are 5 and 7. So I have 5 plus 7 over 2. And my y values are -2 and 5. So I have -2 plus 5 divided by 2. 5 plus 7 is 12. And 12 divided by 2 is 6. -2 plus 5 is 3. And 3 divided by 2 is 1.5. So my midpoint is 6, 1.5. Number 2. If the midpoint of segment AB is m -6, 9, and A is 4, 1, find B. So in this question, we're actually going to go backwards. I'm given my midpoint. So in this case, I'm given my midpoint of m, which is -6, 9. And I know that A is 4, 1. So what we're going to do is we're actually going to do a translation. So we know that in a midpoint, we have two congruent segments. So I know AM is congruent to MB. So over here, this segment is congruent to this segment. So I have to ask myself, how do I get from a 4 to a -6? Well, to get from 4 to a -6, I have to take away 10. And then to go from 1 to 9, I have to go plus 8. So I'm going to do that rule again. So when I want to find out what B is, so my new xy, to go from -6 to my new x value, I have to do -6 minus 10, which will give me A, -16. So my new x value is -16. And my y value I'm going to add 8 to. So I'm going to do 9 plus 8, and that will give me my new y value. 9 plus 8 is 17. That is my missing endpoint. So if I were to do the midpoint formula on 4, 1, and -16, 17, I would get -6, 9. Okay, so ladies, if you're going to look at this, you're going to notice that there's a lot of things we have to fill in. So please make sure you write down all these visuals, redraw them, and you write down the statement you would write and the reasoning. So this is basically like when I write this or when I say this, you write this. So in the first example, here's how it would be displayed in a proof. You would be given this. It would say M is the midpoint of AC or something else. Whenever you see the word midpoint, I want you to think of congruent segments. So if I look, I know that M is the midpoint of this line segment. So I can say that line segment AM is congruent to MC. That would be my statement. I would say AM congruent to MC. Now, my reasoning would just be a midpoint creates two congruent segments. And you can abbreviate midpoint. And that's all you'd have to write. A midpoint doesn't tell you anything else. It just makes these things happen. So I can say AM congruent to MC, and the reasoning is a midpoint creating two congruent segments. Now, in our next example, line segment GH bisects line segment DE. So if I look at this, whenever you hear the word bisect, it's very similar to a midpoint. It cuts this line segment right here into two halves. So it cuts into two equal halves. So in a way, GH is acting like a knife. So I'm going to highlight the segment GH. And what it's doing is it's bisecting line segment DE. So when I'm bisecting line segment DE, I'm cutting DE into two equal halves. So I can say DF is congruent to FE. And the reasoning is a bisector creates two congruent segments. A bisector creates two congruent segments. Our next example. Ray DC bisects angle BDA. So again, whenever you see the word bisect, I want you to say that that means the word cut. So I'm cutting angle BDA into two equal halves. In two halves. But here's what's nice about angles. We actually don't need to name them. What we can do is we can put numbers. So if you look, I'm bisecting angle BDA. What I'm going to do is I'm going to number these angles. I'm going to put a 1 here and a 2 here. You can put whatever number you want. You can put a 3 and a 4, it's 6 and a 20, whatever your heart desires. I'm now going to highlight in red my angle bisector. So when I have a bisector, we just said it, we are creating two congruent halves, or two halves. So I can say angle 1 congruent to angle 2 by using a semicircle. So angle 1 congruent to angle 2, and my reasoning would be an angle bisector creates two congruent angles. And remember, this is what you would be writing in a proof. AB and CD bisect each other at E. Remember, bisect means that they're cutting in half. So we can say, well, if AB bisects CD, I can say my segments are congruent to each other. I can say AE congruent to EB. And I can also say that CE is congruent to ED. Be very careful. Notice I'm not using one tick mark on each of my segments. I'm using 1 on my AE and my EB and 2 on CE and ED. Okay? Because they're not all congruent to each other. And your reasoning would be a segment bisector creates two congruent segments, which is exactly what we wrote up here. Now, BA is perpendicular to CD at B. So this is a two-stepper. Whenever you have perpendicular, you need to say these two things. So if I look, I can say BA is perpendicular to CD at B. We know that whenever we see perpendicular, we're dealing with right angles. So what I can do is I can make this an angle 1 and an angle 2. The first thing I can say is angle 1 and angle 2 are right angles. And my reasoning would be perpendicular lines create right angles. Okay. That's the first thing I can say. And what do we know about right angles? They're all 90 degrees. So I can actually say that angle 1 and angle 2 are congruent. You can't just say angle 1 and angle 2 are congruent right away. You have to mention that they are right angles first. So angle 1 congruent to angle 2. And my reasoning would be all right angles are congruent. This is exactly what you would write in a proof. Make sure you write these down. Okay. AB is the perpendicular bisector of CD. Look, I still have my perpendicular, so everything I said above I can say down here, but now I have a bisector, which we know cuts in half. So this is a three-stepper. I can still say that angle 1 and angle 2 are right angles, so I can put my angle 1 here and my angle 2 here, so I can say that stuff again. So I can basically copy and paste all of this. I can say angle 1 and angle 2 are right angles. I can also say angle 1 is congruent to angle 2 because all right angles are congruent. But now that I have the perpendicular bisector, what I'm doing is I'm cutting this segment right here, CD, in half. Cutting CD in half. So what I can do is I can say CB congruent to BD. And my reasoning would be a perpendicular bisector creates two congruent segments. Eventually, when we really perfect our proof writing, we're not going to have to write all these reasons. We can eventually just say definition, perpendicular bisector, but for now, we're going to say the full reasons. Now the reflexive property. So this is never given to you. You actually get this from the picture. So this happens when you share something in common. So if I look, I have a bunch of triangles. I have actually 3 triangles. I have my whole triangle. I have this triangle. And then I have this triangle. So I have 3 triangles. If you look, I'm going to actually highlight my triangles in different colors. This triangle. And then I have this one right here. If you look, there is some overlap. I have overlap right here. So this is how we mark a reflexive in our image. We use an X, and what we can do is we can just say AD congruent to AD. So whenever you share a piece in your image, that's a reflexive. So AD congruent to AD, and your reasoning would just be reflexive. Vertical angles. If you look right here, they're basically angles that are opposite of each other, and they always make this V pattern. So if you look right here, I have my angle 1 makes a V, and angle 2 sort of makes like an A. See right here how it makes that A? So I can say angle 1 congruent to angle 2, and I can just say that vertical angles are congruent. All vertical angles are congruent. Number 9, linear pairs. So we went over linear pairs very briefly in our lines and angles unit, but we never really did a bunch of examples. So how it works is you're typically going to be given angles that are congruent to each other. So in this case, we have angle 1 is congruent to angle 3. What we can say is, we can say that since angle 1 and angle 2 are on the same line, they're supplementary to each other. And we can say that angle 3 is supplementary to angle 4 because they're on the same line. So the first thing we can say is angle 1 is supplementary to angle 2, I believe, yes. And then angle 3 is supplementary to angle 4. And the reasoning is linear pairs create supplementary angles. That's all my reasoning for angle 1 and angle 3 being supplementary to angle 2 and 4. What I can now do is I can say that since angle 1 and angle 3 are congruent, I can say that angle 2 and angle 4 are also congruent. And the reasoning would be supplements of congruent angles are congruent. Now with this example, it's the exact same thing as above. So in this case, I'm given angle 2 is congruent to angle 3. So I can say that angle 1 is supplementary to angle 2, and angle 3 is supplementary to angle 4. And then my reasoning would be linear pairs create supplementary angles. So I'm just going to copy and paste what we wrote up here. It's the exact same visual. I'm just giving you a different given. Now, I can say angle 1 is congruent to angle 4. And notice I'm using two semicircles this time. So angle 1 congruent to angle 4. And my reasoning would be supplements of congruent angles are congruent. Perfect. Almost done. We have 1, 2, 3, 4. 1, 2, 3, 4, 6 more. There. Triangle ABC is isosceles with vertex angle B. So whenever you have an isosceles triangle, there are two things you can say about it. I can say that my opposite sides are congruent. So I can say AB and BC are congruent. So statement 1, AB congruent to BC. My reasoning is an isosceles triangle has two congruent sides. The next thing I can say is I can say that my base angles are congruent. So I can say angle A and angle C are congruent, or if you want, we can just number them. So I can say angle 1 is congruent to angle 2, sorry, not T. And my reasoning is an isosceles triangle has two congruent base angles. Now, AB parallel CD. So like these are the things that we can just say. So if you look in AB parallel to CD, I can say that angle 1 and angle 2 are congruent because I know that they are alternate interior angles. Remember, this is your parallel symbol. And that's your perpendicular symbol. So I can say angle 1 is congruent to angle 2. And the reasoning is because they're alternate interior angles. So here's what you would write when two parallel lines are cut by a transversal. Alternate interior angles are congruent. In this example, number 14, I have angle 1 and angle 2 again, but this time they're not alternate interior and they're definitely not alternate exterior. They are actually corresponding angles. So I can say angle 1 and angle 2 are congruent to each other again. So for this one, I can say when two parallel lines are cut by a transversal, a transversal corresponding angles are congruent. In our next example, number 15, I have angle 1 and angle 2. I still have my parallel lines. I can still say that angle 1 and angle 2 are congruent, and that's because they're alternate exterior angles. So my reasoning is going to be the exact same as I've been saying before. So when two parallel lines are cut by a transversal, but this time I'm going to say not corresponding angles, I'm going to say alternate exterior angles. And last but not least, I have angle 1 and angle 2 on the same side on the interior. They are not congruent, so when they're not congruent, they are supplementary to each other. So I can say angle 1 and angle 2 are supplementary. So my reasoning would be when two parallel lines are cut by a transversal, as you can see, it's very repetitive. When two parallel lines are cut by a transversal, the same side interior angles are supplementary. Remember, angles on the same line that are supplementary add up to 180. So now in this example, my triangle sort of like rotated, so it's turned over. CD is perpendicular to AB, so this segment right here is creating my right angles. So I can say I have a right angle. Ooh, that doesn't look nice. I can say I have a right angle right here at 1 and at 2. So remember, whenever you have perpendicular, you can't just say that they're congruent. You have to do 2 steps. I have to say angle 1 and angle 2 are right angles. So I can say that they're right angles, and my reasoning is because perpendicular lines create right angles. And then, last but not least, since I know that they're 90 degrees, I know that they're going to be congruent. So I can say angle 1 congruent to angle 2. And your reasoning will be all right angles are congruent. And that's it. So you will realize that we're going to be doing this for the next few days. So it's not always going to be parallel, perpendicular, or bisector. There are other things that we will be looking at. So please make sure that this ed puzzle is completed. And remember, if it's done by 2:00 p.m. today, the day it is assigned, January 6th, 2021, you'll get an extra point on your ed puzzle. As always, if you have any questions, email myself or Miss Daniel. Miss Daniel will gladly help you today during second period if you have any questions specifically on how we were able to make some of these conclusions. All right. Have a great day, ladies.